Not quite sure actually.
So what did you get?
It's equal.
Okay, this is a tough question, which some of these will appear tough questions. Can you share what you've worked upon? But you have to mark an answer. So what is that?
The equal.
No. If you're stuck in such kind of questions, think logically, okay? A is what? Difference between area of larger circle and area of square. And B is difference between area of square and area of smaller circle. If you think logically, A will be bigger than B. High chance. I'm not saying always.
Yeah.
Because larger it gets, the absoluteness of the difference also increases. Yeah. So if I were you and if I did not have time or if I'm stuck, I would have marked A. A is greater.
What was the reason for that again?
Reason is because you have a square, you have a smaller circle, then you have a larger circle inscribing the square within that. Okay.
Yeah.
Now, whenever figures start to get larger, the difference between the smaller and the larger figures will keep on increasing.
Mm-hmm.
Always observe.
Yeah.
So this is a tough question, but if you think logically, intelligently, you will mark A.
Yeah.
If you don't have time or if you're stuck,
Mm-hmm.
and you will mark A and you will come back to it if you have time later.
Yeah.
So whatever sometimes there are some questions where you feel it's going to take you time. You're not able to crack the question within, and also you have to set a time limit for yourself. Okay. More than 1.5 minutes, if you're not getting the hang of the question, leave it and move ahead. Put it for review or mark an intelligent guess. So here
Mm.
an intelligent guess will be the difference between smaller and larger keeps getting larger as you move up the ladder.
Yeah.
Okay. And hence, mostly A will be the right answer and not B.
Mm-hmm.
Now, the question is, how will I solve it? I will try to solve things wherever possible in a structured, organized, tabular format. Okay. Wherever possible. So, here,
Yeah.
difference between area of, okay, now let's go back to the context. Circle is inscribed in a square, and that square is inscribed in another circle. Okay. So can I say the figure looks like this?
Yeah.
I'm going to just put this on a slide. Okay. Now, clearly, the smaller circle inscribed within the square and the square inscribed within a larger circle. And it looks like this. Were you able to draw this?
Yeah.
Okay, nice. All right. Now observe that side of the square you can, or half the side of the square you can assume as x, which can I say is also the radius
Yeah.
of the smaller square. So this is x, this is x, this is 90 degrees. And so we have defined the side of the square, which is 2x now. We have defined the radius of the smaller square. The only thing left is radius of the larger square to find the area.
Yeah.
Which can I say is this diagonal, half the diagonal. And can I say
Yeah.
this is x, this is also x, it's a square, and
Mm-hmm.
hence this diagonal is root 2x.
Yeah.
Now I will put the areas. Areas of, let's start with the smaller circle, then the square, and the larger circle. Okay. Area of the smaller circle, can I say is the radius is x. So pi x
Mm-hmm.
square.
Yeah.
Area of the square, can I say is the side is half the side is x. So
Yeah.
can I say total is 2x each side? So 2x whole square.
Yeah.
And can I say the larger circle, the area seems to be pi r square, and r here is what? Root 2x. So pi root 2x whole square. That's it. So simplified, pi x square, 4x square, and 2 pi x square. They are asking the difference between square and smaller circle and square and larger circle. So
Yeah.
difference between square and smaller circle, can I say is 4 minus pi? And can I say
Yeah.
everywhere x square is common, so I can just delete x square
Yeah.
because it's the ratio relative, right? So 4 minus pi, and difference between large and the large circle and the square is 2 pi minus 4.
Yeah.
Okay. Now, can I say 4 minus, so pi is 3.14, you can assume.
Yeah.
And 4 minus 3.14 is 0.86. And 2 pi minus 4 is 2 into 3.14, which is 6.28 minus 4 is 2.28. So clearly, 2.28 is greater than 0.86.
Yeah.
And the question is, uh, area of the larger circle and the area of the square, the difference, which is A. And actually, this is A and this is B. So A is larger than B.
Yeah.
Okay.
Yeah.
Do you think it should take more than 2 minutes to solve this? No. So what is the learning from this question?
Um,
If many things are inscribed within each other, okay,
yeah.
their areas are a function of their sides or their radius. All that you have to do is find radius, find side. That's it.
Yeah.
Okay. I have a question. Okay. Anything else? What else was the learning from this?
Um, as the figures get larger, you can assume that the difference also gets larger.
Yeah. And you can see, right? The difference
Yeah.
here is, sorry, can I say it's all these, right?
Yeah.
Okay. Yeah. Can I say this, see this and see this? Compare.
Yeah.
Can I say this is way larger than this?
Yeah.
So hence answer should be A. Gut feel answer. But
Yeah.
obviously we have to solve it to
Yeah.
to be sure of the answer, right?
Yeah.
And look at how I have put things. I put things, all the areas together and just subtracted. So neatly we've put everything stacked. organized, easy to analyze, easy to solve. Here, the important thing is whenever it's an inscription question, square inscribed um in a circle, circle inscribed in a square, a polygon inscribed in a circle, or something inscribed in a semicircle, we don't care what is inscribed within what. It all boils down to the relationship between the side and the radius. That's it. So that is the key to solve this question. Relationship between side and the ra radius or the radii here, because there are two circles.
Yeah.
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 Very important concept. 100% this will be tested on the GRE. If you just focus on what I say is 100%, 90% is 50%, you'll get a list of at least 10 questions which will be directly solved from what I will say it will come. Yeah.
Yeah.
So definitely you can expect one question on inscription. Something is inscribed within something. Very, very popular question. Now I will give you a hypothetical case.
Yeah.
Again, there's a circle. Okay. And there is a hexagon inside.
Yeah.
It's very rough, sorry, but
Mm-hmm.
it's a hexagon inside a circle.
Yeah.
So circle and a regular hexagon. What is the ratio of the area of the hexagon versus area of the circle? And no multiple choices given here. And there are some questions on GRE where there are no multiple choices. You have to answer in the box.
Yeah.
So can you tell me what will you do here?
Would you say that the radius of the circle is x, and then you get the area, which is pi x squared, and then you get um
Very good. So I form the
and then
center of the circle and I draw some radius, correct? All
yeah,
these are diameters, can I say? Passing through the
yeah,
center of the circle. And can I say, as you rightly pointed out, each side is, can I put it as R, radius of the
yeah,
circle? So we know area of the circle definitely will be pi r square.
yeah,
Now the question is, what is the area of the hexagon? Can I say, if I look at the hexagon, there are, can I say 6 sides to it?
yeah,
And can I say sum of all the internal angles here is
mm,
360 here?
yeah,
So 360 divided by 6 will give me 60 degrees is what? Each angle.
yeah,
Each central angle is 60 degrees. And if that is 60 degrees, can I say this becomes equilateral triangle?
yeah,
Because these two angles are equal, but one of the angles is 60, so the sum of the other two angles is 120, and the two sides are equal, so the two angles are equal, so each angle becomes 60 each. So can I say the third
yeah,
side is also R, which means it's an equilateral triangle. So area of the hexagon, hence can I say is root 3 by 4 into R square. We have done this, right? Area of
yeah,
equilateral triangle, root 3 by 4 into R square. But how many such equilateral triangles are there? 6.
6,
So multiply by 6, and that's the answer. So r square goes
Yeah.
off, and that's your answer. Yes,
Yeah.
fantastic.
Yeah.
Any questions for me?
No.
Okay. Hmm. Okay. All right. So this is, so you could be asked, circle is inscribed within the polygon or polygon is inscribed within the circle? Two
Yeah.
variants, right? So we have done hexagon or polygon is inscribed inside the circle.
Yeah.
Got it?
Yeah.
What if I told you the opposite? Circle is within the hexagon. What changes? So hexagon and a circle is within the hexagon. So area of circle divided by area of hexagon. How will we find?
Um, would you get the radius of the circle and set it as x, and then you can get the area of the circle with that x, so pi r squared. And then you could cut the radius of the circle could cut the one of the triangles of the hexagon in half, and then you'll have a 30, 60, 90 angle. And then
Okay. Is it
you
something which
can
I've
get,
drawn?
yeah, no,
No, yes. Can you draw it and send
no,
it to me?
yeah,
It's coming back in a minute.
yeah,
right?
I've sent it.
Shared it?
Not yet. It's still loading.
Not received it.
Uh,
Now,
now.
so X is the radius you took
Yeah.
of the circle, okay? Fantastic. All right, let's do that. So there are two approaches. You can take X as the side, or you can take X as the radius, whatever is convenient to you. So you're saying you will take this as X, correct?
Yeah.
And that's 90 degrees. And can I
Yeah.
say this is 60, so this is 30 each,
Yeah.
right? And area of circle will be pi x square. X is the radius, right?
Yeah.
You only set
Um.
it up. X is the radius.
Yeah.
So pi x square, area of the circle. What is the area of the hexagon now?
Um.
Half base into height into 6, correct? Now, can I say height we know is x, and we
Yeah.
also know 30, 60, 90 rule.
Yeah.
1 is to root 3 is to 2. And can I say we know the side opposite to 60 is what? X.
X.
Can I say this is x?
Yeah.
So what is side opposite to 30? Is half base, right?
Yeah.
So what is this? So can I say this is x by root 3?
Yeah.
Yes.
Yeah.
And so this is x by root 3. And this is also x by root 3. So can I
Yeah.
say base becomes what? 2 by root 3 into x, or
Yeah.
2x by root 3. And now we can find the answer. So this becomes pi x square will cancel out. So pi divided by half into 6 is 3. 3 into 3, 2 by root 3 is root root 2 root 3.
Yeah.
Yeah.
I actually did it a different way. I used the equilateral triangle um formula, not the 1/2 times base times height.
Okay. And how will you use equilateral triangle formula?
Um, so I got the 90-degree angle, which was x over root 3 times 2. And then I squared that and multiplied by root 3 over 4.
Yeah.
And then multiplied by 6 because you have 6 angles.
Okay. Fantastic. And did you get the same answer?
Uh, yeah,
Fantastic. So what you did was you set it up as 6 times area of equilateral triangle, which is 6 root 3 by 4 into s square. Now s is this, correct?
yeah,
And s is the one which is the hypotenuse opposite to 90, right?
yeah,
And we have opposite to 60 as x, correct?
yeah,
So in your setup, I'll write it here. In your setup, 1 root 3 is to 2, you're saying the opposite to 60 is x, and you want to find this, right? So that is
yeah,
2x by root 3.
yeah,
Yeah.
yeah,
Okay. So let's put it here. So 6 root 3 by 4 into 2 by root 3 whole square x square. Yeah, you should ideally get this same thing.
Yeah.
And you will get this because this is 4. 4 gets cancelled. You have root 3. Okay, this is 3 and this is 6. So it's 2. So you get an x square cancels because of pi x square in the numerator. So you get 2 root 3. Same. Have to get the same answer.
Yeah.
Good. So multiple ways of solving it. But I hope you get the gist. In inscription kind of questions, it's relationship between side and radius.
Yeah.
Okay.
But do
So
you
these
think there
are
would be,
popular. Hmm.
do you think there's a quicker way to do this, or was my way a bit too long?
I think both are equivalent only.
Even the previous method, I think that you were gonna do.
Which one?
Uh, did you have
The
the same method in mind where you take the radius first of the circle, or is there a way to do it with the
okay. So
side of
I
the
can also
triangle?
take this as x. I can take this as x.
Yeah.
But then you'll have to find what this is. What this is. So this, can I say, is clearly opposite to what? Which angle?
Um, which
60.
one? Oh yeah, 60.
Opposite to 60, right? So
Hmm.
we can set it up like this. Same thing it is, right? So
Yeah.
this, so 30, 60, 90, where 90 is x and you have to find 60.
Yeah.
But you know the ratio is 1 is to root 3 is to 2.
Yeah.
So what is this? This becomes root 3 by 2 into x.
Yeah.
Cross multiply, right? Root 3
Yeah.
into x by 2. So this is root 3 into x by 2. So that's your height. And can I say your base is x only? Your
Yeah.
height is root 3 x by 2. So hence, in this method, area of the hexagon is equal to half base into height into 6 times. And that will be
Yeah.
half base is x and height is root 3 by 2x 6 times.
Yeah.
Yeah. So root 3. Can I say 3 root 3 by 2?
Yeah.
But then your area of the circle will not be uh, pi x square. It will be pi into root 3 by x by 2 whole square because this is the radius, right?
Yeah.
This is the radius and this is also the height. Okay.
Yeah.
Ultimately, we'll get the same answer.
Yeah.
But apparently, what you did was easier because at least area of the circle is directly x square, pi x square.
Yeah.
In this method, both will be roots and roots.
Hmm.
So what you did was a better setup in terms of calculations, faster.
Yeah.
Cool.
Yeah.
So method 1 and method 2. And obviously in method 2, we can set up area of circle. as this
Yeah.
area of circle will be nothing but pi into r square, and r is root 3x by 2 whole square.
Yeah.
This will be pi into 3 by 4x square. So now
Mm-hmm.
when you divide the two, you will get the same answer, pi by 2 root 3.
Yeah.
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 Good.
Mm-hmm.
Nice questions. Good. I think we solved some good examples today. Learned a
Yeah.
few things, which are some advanced concepts. So we've learned